Welcome back to episode 2 of Going Solar. This is where we're going to put a solar power system on our house. So in the last episode we made this custom cooling cabinet and then modified housing to put all that together, and then we get it hung up on the wall nicely like that. We've got the vents for the in and the out, and then also had a little look at the battery storage system, made up a little mock-up battery. Of course what we need now is to make some custom shelving, so that's what we'll get onto in this video. Be a little bit of CNC machining just to machine some of the slots out. Yeah, if you've got the machine, why not? Makes life a little bit easier. And then we'll just get on to welding it all together and then try it out, and hopefully it'll be strong enough and hold those batteries. I think about 30 kilos each. So we'll get that mounted in the cabinet, ready for the installation. So welcome back to episode 2. This time we're going to modify those battery racks so they can take all the weight of those big heavy batteries. Okay, as I showed in the last video, what they give you to hold anything in that rack is these tiny little L brackets. Now admittedly it's a lightweight studio rack, it's not meant for heavy gauge equipment, so most cases this is probably fine. So this bolts into the side, but you end up with the battery only being supported on about the last, maybe that much, 8-10 mil, and the same on either side, and then it's bolted in at the front via the normal racking system. So I wasn't very happy using these, so we need to make some much beefier, more heavy gauge brackets. So this is actually an assembly drawing, but there's enough information here to make all the, well, basically the two parts I need. So there's a bit of 50mm by 50mm angle iron. How long is that? Yeah, 245 long. And then I'll weld onto that this plate that's got a slotted hole in it, and then that will bolt into the rear holes on the rack system. And with the slots there, it gives me the opportunity to vary the height and fine tune it. And then these two holes, they will bolt through into the side pieces that are inside the rack unit, and they've got a slot in them. So essentially I'll be able to move this tray or this shelf up and down any position I like. There'll be one of these on either side, and I think I'm going to make 8 of these, so 4 pairs, 4 left, 4 right. So let me show you the material I've got to make this and how we're going to go about doing it. So I've got 3 lengths of the 50mm angle iron, 3mm thick, and then a little bit of this plate. It's also 3mm, so we just need to cut it all down. And prices for this sort of stuff's gone up, so just what you see there, so 50 by 50 by 1 meter, 3 off, and then this little strip here, again 1 meter long, all came in. So the little strip was £8.53, and those 3 angle irons £46, so delivered £52. But these batteries are very expensive, I don't want them to fall, so we need a heavy duty shelf solution, and this seemed like the easiest way to do it. I couldn't find anything online that was anywhere near like it was going to do the job, so custom brackets it is. So because we've got 8 of these to do, I'll kind of set it up in some kind of fixture, or make sure when it's in the drill, I've got some kind of backstop so I can kind of batch produce these. And so I need to start by initially marking it all out and working out how best to approach it, so it's easiest to make basically 8 multiple copies. Right, let's get going. Okay, we'll chop these down to size using my little portable bandsaw. I've been pretty pleased with this, although recently I did an angle cut. I put it around at 45 degrees, and then when I straightened it back to 0 again to do 90-degree cuts, it's not cutting straight as in when you go down, up and down. So I'm not really sure what's going on there. I'll have a look at the blade again, see if there's anything I can do about it. I mean, it's pretty good, but it's just lost a little bit of accuracy in the vertical sort of squareness. But it does a reasonable job. And here is the length, so I'm making use of the backstop there so I can get 8 all the same. Okay, now we've got to drill a couple of holes in it, so I'll edge fine off the end of that and off the rear face, and then I can move across to the position I need to drill those holes. And because I've lined it up with the edge of the vise down here, I can quickly repeat this setup and we can get all the parts through. I've got to be a little bit careful because I've got to make 4 of one hand and 4 of the other, and just make sure I don't make 8 of all the same hands, so some go on the left and some go on the right. Right, let's pick up this edge and then we can start drilling. So I'm sure you've seen one of these before. I'm just using the edge finder there just to pick up the edge, and as you get close it runs straight like that, and then suddenly it will just kick out. And when it kicks out, that's at the edge, and then it's depends on which one you're using. And there I'm using the 10mm one, so it's 5mm from the edge. There's a smaller, I think it's a 4mm one at the bottom. Yeah, so we put 5mm offset. Do do the same at the rear. So it's coming in, straightens up, and then when it's touching that surface, or it's 5mm away, kicks out. Type that into the digital readout, and then we know where our 0 is. So we've got 0, 0. And then we can move the y-axis in this case over to the correct point. I think it needs to be 11.5mm from the end and 50.5 from one edge. So yeah, it's very handy, that little DRO. And then we're just going to center drill this, or spot drill it, just so the drill doesn't wander when we finally drill the actual size hole that we need. So I've been very pleased with this build. I think it took over 2 years to modify this drill to have all these different functions, but you know, it's really nice now. It does exactly what I want it to do. So we've got the correct twist drill in now. And so we've just got a little piece of wood under there, just so I don't drill into the vise. That wouldn't be good. And then just to finish off those holes, countersink them. Oop, try again. Countersink them so there's no sharp edges. There we go. So we've made 4 of one hand and 4 of the other. Okay, so we've made 8 of those L-shaped pieces, 4 left and 4 right hand, and then we just need to make this little rectangular piece here, and it's got a slot down the middle, and then we'll weld it on. So I've got this strip. I ordered it the correct size, so I've just got to cut it off to length, and then we'll mark it up, get it over on the surface plate, and then mark out the slots. Then we'll go to the CNC machine. I think I'll just set one up, do the groove manually between 2 coordinates, you know, just use the cursor keys. Once I've got that dialed in, then I can just drop all the parts in and machine the slot quickly and make, we're going to make 8 of them. And although the slot is offset to one side, if I make them all the same, I can weld 4 on that way round, then 4 on the other way round. I've just got to make sure the weld bevels are correct, you know, when I do that. But that's all fine. So we make 8 exactly the same. Let's get going. Okay, so I just roughly marked it out and then chain drilled most of the material away, and then come back because the marks weren't that strong, so I've just made them a bit deeper. So that'll make it a little bit easier on the end mill because we are machining steel after all. So you know, it's a router, it's really for high speed. So we'll get this set up, and then once I've got one set and I can get it set relative to the vise, should just be able to put all the other 7 in and just machine them out without having to mark it up. Right, so that's our first one. Let's go set that up, machine it out, and then we know what we're doing. Okay, we're over now at the CNC machine. So I've got the vise trammed in, I've got the part in there. I've just touched off the sides and got it lined up with one edge, zeroed it on the DRO. So we'll just manually machine that out. And then the next one we can just drop in, line it up with the edge of the vise, and just repeat without having to mark it out. Now this is a high-speed spindle. It's a router really for machining wood and things like that. It will cut the steel, but it's got no torque at low RPM, so you end up running the spindle a little bit too quick really, especially for the 6mm end mill. So you know, it is cutting it, but it's probably not doing the end mill any good. So I just use it for occasional bits of work like this. If I can get away with it, I'll try and use a 4mm end mill, but you know, this slot I think was 7, so I thought, well, let's just go for it with the 6, and then we can just open it out 1/2 mil each side. So you can see why I chain drilled it out first, because it's taking bites there, and you can tell it's running really rather too quick. And then here I'm going down to full depth and just machining the slot completely out. And then once I got to the end there, I just moved it 1/2 millimetre each side, and then that made the 7mm slot. After I've done this a couple of times, I decided to write a little bit of G-code, and then it would just cut out a rectangle. So I'd just go down to each depth in turn, then it run that bit of code, and it cut the next rectangle out. You can see it there in the bottom left corner. Nothing too fancy, just a simple bit of G-code. This is the UC CNC software, which I really like. It makes life a lot easier for using the CNC machine. There we go. Okay, as you can see, I've done all 8 now. Put the slots in. I've radiused that on the belt grinder just so it fits in the corner nicely on the angle iron. Now I just need to put a weld prep on there with the angle grinder, then we can get welding. Okay, so I've got the first one set up here, I've got it nice and flush, so we'll do 2 little tacks and we'll take that off and do a little stitch weld here, there, around the other side, and I think that'll be enough. I don't want to go overboard on it. Right, so I've got the filter on, so hopefully that'll protect the camera. Yep, let's get some welding done then. Okay, so I've got all the brackets made, and I thought before we go too much further and get them sprayed up, I'd make sure they fit, just in case I need to fettle them or grind them a little bit. So I've got 2 offered up there, and then down the side there I've got it marked up with the battery management system at the top, and then a bit of a space, and then 1, 2, 3 cells, or 3 racks of cells, and then I've got space down here if we need to put a 4th in the future. Then the only other thing is the cable management, kind of passed through at the top there. I've pushed it up so it's actually inside the frame, otherwise it was never going to fit with everything, and I think there's still room to get all the cables through at the front, and we'll do the same at the back as well. So I'll get my little cardboard template back in. And then you can sort of see what I've been doing there. So I've got the little brackets just nestled up against that and make sure it's all going to go. So I'll just put a few more in, make sure it's good, and then we'll strip those down and paint them up, and then I think that's the brackets done. So while we're waiting for the installation, I thought I'd have a look at the app that comes with this Fox ESS system that links up to the inverter. So this is a little screenshot of it. I managed to find this by somebody who's put a video up online. I'll put a link to it down below because it's quite interesting, the things they've found, and obviously they're quite into all this side of it. And as you can see, it shows you what's coming through the panels, it shows you what your battery's doing, what the inverter's doing, and what the grid is doing. The downside is, though, as far as I can tell from this information in this video, it's only uploading that information or only putting it out every 5 minutes, so it's like snapshots in time. So if you happen to be turning on a kettle, or there's a bit of load balancing going on which only lasts a few milliseconds or half a second or something, that snapshot will be captured, and that's what will show on your display for 5 minutes. Now I believe you can make that update a little bit quicker, maybe 1 minute, 2 minutes, but it's not live, and it can make it a little bit confusing. Now it is still storing all the data. It's storing the live time history of that data, so when you look back in time over the past day, week, that is correct. It's just when you want an instantaneous view or a live view, that isn't really possible with this system. Now there are ways around it, and he went into that a little bit later in the video, where you can use Modbus and then download Home Assistant was the one. There we go. So he's got another program called Home Assistant, which I think is a bit more generic for running your house. And then using the Modbus, he was able to look at the different outputs, and there was about 30 or 40 different parameters you could have. And then you could make a custom dashboard here. He's got where the energy is going, and it runs pretty much live, so it's quite a nice way to look at it. But then you need Modbus, you need another program called Home Assistant, and it's getting a little bit complicated. So at least I know this is a future option if I want to look at live data. But I need to get into something else as well, another complication, and maybe the way I'm going to make this simple for myself. Okay, this is an example screenshot I found off the internet about all the things you can add on the My Energy system. So we've currently got the My Energy system, so we've got the Zappy car charger, and then through that app, you can see what's flowing through the system from from the house or into the house, from the grid, whatever. So I can see these top 3 icons. In the future, when we get the Eddy hot water system, I think that's that one, we'll be able to see what that's doing. But if we just go ahead with the install and use the Fox ESS system and use the app I just showed you earlier, I won't be able to see these 2 here because there's no sensor there, there's no information going to this system. So what I want to do is set up a CT clamp on the solar generation side. Now the downside is, because it's between the PV system, the inverter and the batteries, it's all DC. Now CT clamps only operate on AC because they're an inductive type of probe, so you can't detect those. But what I can do at least is detect the output from the combined version of that comes out of the inverter, which is AC. Now obviously if we end up doing something a bit unusual like charge the battery from the grid, that will be a bit weird because it will be negative going into that system, but for the most part we'll be generating power live, or we'll be using the battery to run the house, so it will be coming out the inverter and we'll be able to see everything real time on your phone wherever you are in the world and see what's happening, and not have to log on to the Fox system and just see instantaneous, or sorry, every 5-minute values. So this is the plan. So let me show you how I'm going to show that, set that up in the workshop to achieve that, or at least what I think is going to work. We will find out. So this is what the My Energy app looks like on my phone. So as you can see, we just got the house, the grid, and then we've got the electric car on standby, so that will come on tonight, so it's on pause. And then we're hoping to add some kind of solar generation one down here and the Eddy for the hot water system. And it's a really nice app, so it's all in one place, and you can do things like, if we go and look at the grid, we can see, so we're currently bringing in 400 watts and we can see what's happened today. So this morning the washing machine came on at 2 o'clock, so there's a bit of a peak there in the morning, and then I got up at 6 and put the tumble dryer on, and then I think that was probably breakfast, having a cup of tea and things like that, boiling the kettle. Then around midday I did a Sunday roast, so that used the electric oven, and then we were out most of the afternoon, so you can see it's just trickled along, and then we just had a bit of a snack for tea, so we didn't put anything on there. And you can see we've used about 10 kilowatt hours, so typically we use about 13 during the day, and then you can work that out over the year. So it's a really nice app, so hopefully we'll add the extra sort of things off the bottom here, and we can see the whole thing in one place and not have to go into that Fox ESS app, because I'm pretty sure this is real time, so it'll be really nice to do that if we can get it to work. So to monitor that generation from the panels and from the battery, as I said earlier, because they're DC you can't measure those directly. I can only measure what's completely combined coming out the inverter as AC. So I've got, let's start here, I've got a little CT clamp, current transducer or current transponder, whatever you want to call it. And then the idea is this goes around either the live or the neutral. I guess live might make a bit more sense, but as long as you pick one and get the arrow in the correct sense. So you can label it up which one you've got around there. That's if you've got 3-phase, so if you've got a 22 kilowatt inverter, say, and then you can mark it up as to which one it is. I'll probably put the panels, although technically it's panels and batteries for this one. I've got another one on the grid coming in that's connected up to the Zappy charger, so it's probably got that on there. Well, I didn't put that in, I guess it's got that label ticked. So that's the sensor. It comes with 5 meters of cable. Now it's a little bit too far and awkward to get all the way back to the Zappy. I could do it with an extension, but it gets a bit messy with the wiring. So I've gone for this Harvey units. This is self-powered, so it takes power from the current flowing through the wire. I think it needs 50 watts of current flowing. Then it comes on and then it wirelessly transmits this back to the master. So in my case that will be the Zappy charger, and you've got up to 3 terminals there. I'll actually be using 2 sets of those, I'll tell you why in a minute, but the main sensor there for the solar generation will go into the first one. And then this one I'm going to actually put 9 volts of power in. I'll explain why. Let's go over to the wall and see what it looks like over there. So if we open the cabinet, I've just put an extra run of this conduit stuff here, some cable ties in it ready to take some wiring, and then when it's closed it'll look like that. And the inverter and the box and everything will be on here, and then we've got our plug up there, so there'll be an AC feed just after the isolator that they'll put in, powers that. One of those goes to the cooling fan for the IEC cable for that runs the cooling system, and then the other one will go to a transformer that will plug in transformer. It will give 9 volts permanently into the Harvey. So as I said, if it's dark or your batteries are flat or whatever, and you're not actually generating any power, that will go off and then take a few moments to come on again. So by permanently powering it with the 9 volts, it'll stay on all the time, and then they can make a neat job of that, the wiring there. And then I've also got some of the 20mm conduit, some saddles, you know, whatever, just to bring that cable down to here. I'll probably put 2 S-bends in it, and then they can carry that cable on to wherever it's got to come out down here. I'm not exactly sure where it's got to finish, so I'll let them do that bit. So there's our little Harvey unit, so that will clip into there. That gives you a bit more of an idea about what it will look like when I get the cables on there, and you'll hardly see any of that because the box comes out like that, unless you're up on a ladder or something. And then that goes down to there. That's the plan anyway. Okay, it feels good to have all the preparation done. So I've also got a date now for the scaffolding and a date for the installation. So watch out for that in an upcoming video. In the meantime, thank you very much for watching. Hope you've enjoyed this, and we'll see you next time.